Good morning. Namaste. This is Dr. Uma Kedvetal, Faculty of Agricultural and Veterinary Sciences, Jayoti Vidyapeeth Women's University, Jaipur. As you know, I'm taking the course on Metabolism and Bioenergetics Lab. So far, we have covered how to use a spectrophotometer, how to determine reducing sugar levels in a solution, and also determination of starch and how much photosynthesis occurs in a leaf, and then we have gone on for extraction of lipids from oil seeds, its separation by column chromatography, by thin layer chromatography. Now, what do we do after separating all these lipids? So we are going to study one method of estimation of a certain lipid, a very important biochemical lipid at that, cholesterol. So cholesterol is essentially a steroid. It has got a perhydrophenanthrin ring structure in it, and it is biologically very important. It is a precursor molecule for various steroid hormones in our body. It is very essential for proper metabolism. However, if the cholesterol levels are going above a certain limit in the body due to excess lipid consumption or due to faulty metabolism in the body, then what happens is could lead to complications and health issues. So determination of cholesterol levels as such is done on a regular basis in a lot of biochemical labs. It is done using determination of cholesterol levels in the blood samples, mostly for many people. And so many people have to get it done on a very regular basis. So what is the common principle behind the biochemical test for the determination of cholesterol? So there are two main methods that are available. One is the Liebermann Burchard method that we will be covering over here, and another is the Zach's method, which was later developed. So Liebermann Burchard method actually is one of the foremost methods for the determination of cholesterol levels, and it is still one of the leading assay for serum cholesterol in clinical laboratories. And it was it is one of the foremost in this, that it was developed in the early 1885, early 1880s by Liebermann, and was later investigated and extensively developed by Burchard. So Burchard developed the reaction into a quantitative test for cholesterol, and he used colorimetric method, but nowadays we use spectrophotometric method. And we use this assay to confirm the widespread presence of sterols in animal and plant tissues, in blood, and it is not exactly specific for cholesterol. It can be used for other sterols also, but it will depend on the double bond system and other functional groups, and the presence of polar side chains and such. So this Liebermann Burchard is a reagent that is used in colorimetric test to detect cholesterol, and it gives a deep green color. So as I had told multiple times in the earlier experiments, if we have a deep blue-green color, then where will we be using the wavelength to detect it? Yes, it will be in the red zone. So typically what is used is a wavelength of about 610 to 620 nanometers, and the reagent as such is a purplish pink in color. So your blank will be something like a purplish pink color, and yeah, that can be and then it like depending on the concentration, it will give a light green and then a very dark bluish green color. And that color is due to the hydroxyl group of the cholesterol reacting with the reagents and increasing the conjugation of the unsaturation in the adjacent fused ring. So I can show you the image for cholesterol. So cholesterol will look something like this. So this first molecule is cholesterol, and there is a lot of sulfate reactions that is happening over here. So when we are adding it in the presence of acetate, then that is when this reaction is going to happen. So this Liebermann Burchard reaction for steroids is basically adding a few drops of acetic anhydride and concentrated sulfuric acid to the chloroform solution of the sterol. Then it is used as a qualitative test, but it's also used in the quantitative estimation of cholesterol in the blood. So this acetic anhydride, when that is formed, then it will give the carbonium ion of the 3,5-diene of the cholesterol. And then when we are adding it to the acetic, then it will again, like the first will be acetic acid and sulfuric acid, which will give the carbonium ion, which will further react with the acetate in order to give the pentaenylic cation. That has got a absorption maxima at 620 nanometers. But if you are adding further sulfuric acid, then that will have cholestahexoine sulfonic acid that will actually have a purplish color, and that has got a lambda max around 410 nanometers. So like this is a step-by-step reaction, and it has to be stopped at a particular point so that you can get the measurements. Now it will depend on the amount of sulfuric acid and the amount of acetic anhydride that is being used for the reaction. So here we will have sample. The materials required will be your sample, typically blood sample, or you could even have a solution of cholesterol. Cholesterol is a commercially available substance, and so you could even have a simple solution of cholesterol, and or you could collect blood from some source and analyze it for cholesterol. And then there will be chloroform, because as I had told, the chloroform solution of the sterol is used for the analysis in a Liebermann-Burchard reaction. So once you have the chloroform solution of the sample, then we will be adding acetic anhydride and sulfuric acid to it. And so basically 2 ml of the chloroformic extract of the food material or blood or any tissue sample from which you want to detect the cholesterol level, or if you want to prepare a standard curve and you are using commercially available cholesterol, you will be preparing the chloroformic extract of those cholesterol, and to that add 2 ml of acetic anhydride and add only 5 drops of concentrated sulfuric acid. That is because if you have more of the sulfuric acid, then the reaction could process further. So the sulfuric acid is one of the limiting reagents for this reaction. And once this is happening, the bluish green color is the indication of the presence of cholesterol. Now, if you were doing a quantitative analysis, what would you do? So as I had told, this will be measured at 610 nanometers. Now, if you are having to do a quantitative analysis, first thing, like any spectrophotometric analysis, you need a standard curve. So you will take commercially available cholesterol and make various concentrations of this cholesterol extract in chloroform. So this cholesterol will be dissolved in chloroform and this extract, because be very careful with the chloroform, One thing, it's a slightly toxic substance and you could feel nauseous if you inhale it in higher quantities. And another, it is volatile, so there could be reduction in the volume. And also, do not ever use organic solvents in plastic tubes. Always use glass tubes, because chloroform is a very potent solvent and it can actually dissolve your plastic. And so you will be finally having chloroform dripping onto your hands, and your entire experiment will be gone, and you will have this toxic solvent on your hands as well. So be very careful when you are using chloroform to do any experiment. Always use only glass tubes and keep it covered as much as possible. So once you have this chloroform extract of your cholesterol that you have commercially obtained, so make it in different dilutions, and then conduct the Liebermann Burchard test with it using this same quantity of acetic anhydride and a few drops of sulfuric acid. The color will develop, and depending on that, you can get the colorimetric analysis of the cholesterol sample. And once you have this one, you will again be plotting a standard curve. So what was our standard curve again? It will be something like absorbance on the y-axis and uh, the concentration of cholesterol on the x-axis. Now, if you have the standard curve, then you're basically all set in order to continue the experiment. So now you have your sample. So say you want to get the cholesterol content of a food, like you have prepared some new chips using a certain oil, and then in order to give its nutritional ratings, you have to check for its cholesterol value. So you will have to grind this whatever food product you are using, say this chips, and then extract it using chloroform, so that all the lipid will be, all the steroids will be dissolved in it. So this will be a chloroform extraction process. So you could either use a oxalate, because oxalate extraction is a very good process for chloroform extraction. But otherwise also there are other methods also available for extraction, but this will need to be slightly heated up. So oxalate is one of the best methods that can be used for a chloroform extraction from most of the samples, unless you have a lot of impurities in it which will also be dissolved and you want to reduce the dissolution of your compounds in there. But that's mostly not going to happen, because chloroform is potent solvent for lipids and lipid associated products. So mostly what will be coming out will be your cholesterol. And once you have the cholesterol in the chloroform extract, then you will be adding a couple of ml of acetic anhydride, and then once that is added, then you acidify the medium using sulfuric acid, taking care that you are not adding excess sulfuric acid. Once that is done, the reaction will proceed and we will get a bluish green product. So it could be from light green to deep blue green product, depending on, like if the concentration is very low, you could even get grass green for this. So once that is done, you have your sample, and then again measure the absorbance value using the same spectrophotometer at 610 nanometers. Once that is done, you have your absorbance for your test sample. Take the absorbance value and look what the corresponding x-axis value will be for your in order to determine the concentration of cholesterol in the sample. So yeah, nowadays there will be a lot of chips and all saying that there is 0% cholesterol. It's basically that if you have less than 1 mg of cholesterol in the total sample of the sample size defined, and in that if you are having less than 1 mg per gram of the sample of cholesterol, then you can actually put it as 0%, even though it's not as if like cholesterol is totally absent in that sample. But if the value is less than a certain value, then you could round it off to 0 rather than rounding it off to 0.1 or 0.5 or even 1 and putting it as 1%. You could, the value becomes such that you can round it off to 0. And that is the principle behind how we are getting totally cholesterol free products, because it's not as if like it's totally cholesterol free, but it is having cholesterol in trace amounts that could be neglected, and for marketing purposes we could always put it in such a way that the value is 0. So these are all like the commercial applications of this estimation of cholesterol using the Liebermann Burchard method. And it is used for blood analysis as well. And as you know, so many people are getting cholesterol, high cholesterol levels in their blood, and they're taking treatment for that. They need to get this estimation done every now and then, like once in a month or so. So this method is used in labs also on a routine basis. So these are all the applications of this method. With this, we will be wrapping up the lipid section. Next session, we will be covering proteins using Lowry method and Bradford method in the session after that. That will be for now. Thank you. Have a nice day.